Yeah, it's all good.
Awesome.
I can see it. Cool. All right, I can navigate on here, Craig. That's good, isn't it? Didn't know I could do that. Anyway, yeah. So, quick intro, and then I'll jump into some sort of context. But this is a presentation that's going to be about Actor Framework and how we've implemented it in a project that we've recently completed. So I'll just cover a quick overview of sort of what the project's all about, really. So we're working with a company called Envirovent, and they basically manufacture ventilation systems for sort of commercial and non-commercial housing and buildings. So they've got loads of different products, and they obviously, like every company that manufactures something and has a product, quality is one of the things that's at the top of their agenda, and making sure that everything goes out the door right first time, and all those kind of terms that everyone's used to within manufacturing environments. So the reason why they got in touch with us really was they were introducing a series of new products, and with the majority of their products, they've got printed circuit boards in them, and Envirovent actually outsourced the manufacture of the printed circuit boards, but obviously during that introduction of new products, new PCBs need to be manufactured, and what comes along with that obviously is the testing of those PCBs to make sure they do what they're supposed to do when they get into the product. So our kind of remit was to provide 8 new test jigs that would perform tests on the PCBs that were going into the new products. So in terms of requirements, we needed to replace this. So this is an example of one of their existing jigs, and it does the job. As you can see, it's very much sort of...
Hey, Chris, we're not seeing anything update.
What can you guys see? Can you see?
It's still on your front slide.
Or is it?
I think it's next to Craig's one.
Sorry, is that better?
Yeah, now it's moving forward. We're on slide 3.
That's me moving it, Chris. Okay, looks like it's just me that can move it in a strange way. I find it very strange that you can. Okay,
that's weird.
Which slide do you want?
So you should be on slide 5. Is that on slide 5 now? Everyone see the...
Yes, yeah, it's slide 5. You can see the jig.
Older looking jig. Yeah, sweet. Okay, so yeah, this is the previous jig that they had, and as you can see, there's a load of little LEDs on the front at the bottom there that show them each test as it's passing or failing, and they've got a couple of buttons to press to start and stop and pause. So very much kind of manual interaction and not much sort of visualization from a user interface perspective, but obviously does the job, and that's kind of what we were set as our requirements. Obviously, we had a sort of test sequence that was associated with the PCB, and a load of other detail about what kind of interaction was required with it from a sort of programming the PCB perspective, but also test points and sort of setting things via UART and things like that. So quite a lot of interaction with the PCB that needed to be sort of managed through the jig. So this is a bit of a... Craig, can you move on? Sorry, I just moved on.
Yeah, can I just ask first? Can everyone see my mouse moving around with all the buttons on the bottom?
No.
Or can they just see the screen?
Oh, yeah.
Just the screen.
Okay, that's fine.
Cool. So hopefully slide 6 is a sort of diagram view of the solution that we implemented. So you've got a desktop cabinet that contains the things within that kind of box, and then on top of that we've got a bed of nails, which is effectively all of the test points that align up to where they need to on the PCB when it's loaded onto the bed of nails, and then you're obviously able to sort of close the lid down and perform various bits of testing. So there's different types of sensors on that bed of nails and within that lid that enable it to the sequence to manage whether it's safe to operate, and can read the necessary information from the PCB to make decisions and determine whether tests pass or fail. So within the actual jig, we've just got an industrial PC which is connected to data acquisition, and a programmer which is used to actually send sort of the stuff down to the microcontroller on the PCBs. We've also got a calibration panel, so they can connect up external devices to enable them to check and calibrate the signals that are being acquired through the data acquisition hardware. So that effectively sort of created our design for the system from a hardware perspective, and then from a software perspective, Craig will cover that in a bit of detail, but we had a user interface sitting on a little touch panel PC, which you can see at the bottom there, and it had some configurability, and obviously executed the test sequence, and sort of reported pass fail. And it did a few other little bits, but I think Craig will dig into that a little bit when he covers his bit. So yeah, on to the next slide, Craig. I think it's the last one, just to show you a picture of the pad drawing of the actual jig that we delivered. So it looks pretty similar, albeit the front bit looks a little bit more modern with the screen on the front. And yeah, that's we delivered 8 of those, and we're now that was the end of the project, and we're successfully completed. So I'll hand over to Craig to take you through some of the Active Framework stuff and a few of the bits and pieces we got involved in there.
Thanks, Chris. Yeah, so like Chris has already been through the hardware there, so thanks to him for that. And yeah, I was going to do, well, we were going to look at a deep dive, and the more I kind of scratch the surface of the whole project, I realised that this might be more of a whistle-stop tour. So apologies if we don't go too deep, but or if we get stuck and we don't go too far, that's the alternative. We kind of do deep dive on some bits of it and don't get to the end. So yeah, just setting our expectations there. So let me jump in. Quick cover of the architecture. I don't know how well people can see this presentation. On my screen, it's quite grainy, but small, but hopefully you can see that okay. So yeah, we sort of, it was our first real jump into Active Framework based project for a customer in essence, certainly since I've been at the company. I don't know if that's true fully historically, but that's the case as far as I've seen it. So we obviously, I've had a bit of experience with it before, mainly playing around with it, I guess, but wanted to really jump into it. It was something I really enjoyed working with, and found it was very, very useful in terms of abstracting stuff away and modularizing software, and yeah, in general, kind of architecting the whole solution. So a couple of things that we tried to kind of implement on this was, well, one of the main things we tried to implement was like low coupling of software modules. So just making sure that when we're talking back up to the chain of actors, that we've always got this sort of top level actor that's talking downwards to its sub actors, but then messages back up were always through an interface so that we could harvest off modules for use in other projects in essence at a later date, without any coupling back, having messages in them that were part of the actor above them. So we'll have a little look at that in a bit. In terms of an architecture for this software, we had two main top level actor called controller, with 4 sub actors. This asynchronous system exec, which was talking to command line or doing command line stuff for us. We had this event actor, which was basically logging events, an error actor just for logging errors, and a DAC actor, which did most of the work talking to the hardware. Talking to the data acquisition hardware. The other hardware, so the programmers for the microcontrollers on the devices under test were communicated with and programmed via the command line. So there's some software working with them. I'll look into that again a little bit later. But then we've got these other, so two implementations of the controller that were actually used in the software. One for presenting a GUI, and one for presenting a test harness for CI or for manual testing. Got some So one of the main challenges with this bit of software was sort of configuring it for different setups, different test setups for the same board, or so the same device under test. But they've also got multiple devices under test on the same jig, so there are 2 different variants of the same kind of board, different tests for each of those variants, and then we also had 2 different types of jig that were running the same software that we could configure. But we could configure this software to run both jigs, but present quite a different user interface. Well, some different user interface aspects and different tests for different boards and different things like this. So lots of configuration. So we had basically a configuration in it for general setup, calibration in it for defining the I/O stuff, and then these test ini files for actually setting up the test steps in the sequence, firmware packages to be distributed to the microcontroller. So for actually, when the whole point of this jig was to first to program these boards and then test them, so it give the environment, our customer, a full working, from the board being made through to actually having a fully tested board, all in one hit, rather before they were programming on a separate device and then testing. So just cut out a little bit of extra work there. And then we also had this, it's kind of a common, what we've ended up with really is a common kind of component that we can use potentially for new jigs for this customer. It allows them to potentially rebrand it for, if they change their branding going forward, so that it keeps their production line the same, but also potentially for us to allow us to make this for other customers as well. So yeah, so just some image files really for setting up the backgrounds and things. So software modules, like I've already discussed, we've got these 4 sub-actors, and then the controller split into 2. Generally, the theme of all these little modules was that we had this setup where the controller could talk down, but then the module could talk back via the interface, and that's quite a common theme in what we're doing. Just means that we can harvest stuff off for reuse in essence, and make libraries, something that I'll come to later as well. So GUIs. Oliver, I think just on the next page, we've got a little bit of a flow diagram really. So I wanted to jump into GUIs, and I think Chris was quite keen to run through these and kind of just show that we've done something simple, but I think quite clear and effective. So let me share what we've got, and I'll walk through this whilst I do it. So share this. Everyone see that? Everyone, yeah, good. So yeah, everything's from the GUI side of thing. Everything started off with the splash screen, so it's like a launcher. Just run through it first before we jump into it too much. Essentially, there's some loading in the background of all the configuration modules. Remember, this is all touch screen, so this is all sitting on this smallish touchscreen panel. So all these buttons are nice and big for the user to be able to press with their thumbs or fingers. But it's essentially splash screen loads in this main test screen. So right from here, the user can press start and run a test. At the moment, it's set up to doing some simulation, so random stuff happens at the moment. I can set it up to do a particular test and run through a test program, but at the moment it's just simulating all the inputs and outputs. So kind of anything could happen in this test. It could fail, it could pass at any step. But for CI purposes, we had it running in the background. Like, we've got some way of setting up the I/O so that it sequences that, so that we can test that certain things happen and that certain tests pass and fail and things like that. As you can see on this one, it got to this step and stopped. and it's just checking for a discharge resistor that's a discharge capacitor, sorry, that's just discharging. Then yeah, ready to run a new test. So basically that's how the user uses it, or the operators use it generally. They're just putting a PCB in, pressing start, it runs through all these checks, and each line they're checking that certain things happened. They can check, well, if there's more than one test loaded onto this particular jig, then they can run all these different tests to do certain things. Yeah, so we've got some nice buttons for moving up and down that. We can allow it to pause on certain test steps, things like that. So some other parts of the software are, we've got this configuration menu, so that shows us some other sub menus inside there, but also kind of the status of where you know, what tests have been run so far and how many have passed. We can reset from there. We've got a way to upload firmware without running through a test. So the tests we've got set up actually have some of them actually have a programming step, but you can do programming on its own as well, just from here. At the moment, we're just running a simulation mode, so it just is a ping on the command line, and we can upload new firmware from USB. So I've got USB plugged in with some firmware on it, and I can upload that to this folder position. And you can see that's gone into that place now, and it's ready for programming the boards. About screen, general kind of stuff on there, and then calibration interface. So this is useful for us setting up each of the channels on the jig. So and for sort of doing some testing as well. So for each of the channels, we can set the slope and the intercept. We can save the factors to file. We can actually set values as well. So as you can see, there's some dialogues that pop up in this, and all our things had to work with touchscreen. So everything, all these nice things where you normally just type something in, we had to create some user interface for doing that, that would work with nice big buttons. So that was one of the challenges with this. But yeah, that's essentially how we. That's essentially the whole of the software, but from the user's point of view. So let me stop sharing that. I'm just going to go back to the presentation. Good. So yeah, I think been through most of that stuff on there. So that's all the parts of the software and the flow. We can dive into some of these GUIs now. I think it's worth spending a bit of time looking at how we've put those together. So the main sort of GUI layout was done with the main GUI, which had a sub panel in the middle. So we had just this thin banner at the top, where you can see this common UI element, which has got some. You can still configure that with an image for the logo, and the title can be changed and things. But that stayed common to all the user interfaces, and then this bottom banner as well did as well. But then the sub panel in the middle was where we loaded sort of the different interfaces for each of those screens that we've seen. So generally, we've got a little bit of a bit of magic from the Actor framework there, where we've got sub panel, this common sub panel component, so sub panel GUI we called it, and all these the sub screens that sit inside the sub panel were children of that sub panel GUI. So this test screen, the configuration screen, firmware screen, calibration, and the about screen are all kind of inheriting from that sub panel GUI. That it means that then we can inject it into that sub panel using the same messages. Just a little bit of a just an enum to change which panel was shown. So let's have a quick jump into that. Some of the things. So yeah, so this is the sort of the abstract sort of sub panel, which has the messages in for basic. Well, it's just one message for inserting it into another into the controller's sub panel. The main controller GUI looks like this. So this here is a sub panel area, and these are just some of the controls on the front of it. Then the sub panels like the about screen, again, so they inherit from the sub panel GUI, and then they're just injected into this sub panel at runtime by sending this message back to the controller. Or sorry, send the other way. So sending this message to them from the controller. So yeah. So each of the what that meant we could do is we can concentrate on just designing the interface for each of the sort of the functionality for each interface, and then the rest of it stayed common and looked the same because it was the same in essence. Yeah. So all four of them. So these are all the screens that you've seen. Firmware screen, and then we've got the last one, which is the test interface, which is there. So yeah, that's all the four screens. I think one of the things that's quite nice about doing this in Active Framework or doing this in a common framework is that you end up with very similar looking kind of VIs that you know how to work with. So this is the main stuff for the test screen, and if I look at the firmware screen, it looks pretty similar. There's some similar architecture there, in that we've got the user events loop to get any user interaction from the screen, and then everything else is done inside the actor core with messages. So nice and straightforward. Yeah, similar on all of these. I'll not go through them all, but you can see the theme. Yeah, I think so. Yeah, I think that gives a kind of a bit of an overview and a whistle-stop tour, in a whistle-stop tour kind of framework of the of the GUI. So the next thing I wanted to look at was hardware interfaces. So I don't know if it's worth looking at the presentation again, but essentially we've got three bits of hardware that we need to work with in this project, and some simulation of that hardware as well. So we again it's very similar to what we had before with the other GUI modules, where you've got this controller actor talking down to the module itself, and then it talking back with an interface. I best just show this part of things, to be honest. So yeah, so we've got three bits of real hardware. One being a LabJack U6, then we've got the microchip PIC-Kit4 and this FTD I cable. these two we use for programming there's two at the bottom we use for programming the device under test. The LabJack was used for gathering data, so reading signals from and passing signals to the device under test. And we've got, so yeah, as I was talking about, in terms of the actual architecture of these modules, so we basically got the controller talking down to the DAC module, the DAC module talking back via an interface to the controller, and then we've got another interface underneath that, which means that we can inject hardware at runtime depending on which type of hardware we want to work with. So in this case, being one being a simulation and one being the LabJack itself. With regards to the other two bits of hardware, they actually talk via serial via the command line interface. So each of them had a third-party bit of software that we talked to on a command line, and for that we had a separate module that talked on the command line, and we could just set up in either way depending on whether we're working in simulation or in real mode. So I'll have a look at that in a bit. But yeah, that's generally the hardware layout, and but now that's enough on that. What we also worked with on this project, and something that probably jump into a little bit more now, is the testing environment. So for each of these modules that we've got, we apart from the GUI, which I guess was a bit of a problem, but sort of how we tested each of these modules was through Karaya, which presented us with a nice user interface. We did lots of unit tests on all the modules, some nice integration tests on the test harness controller. So separating out the controller into a GUI for the actual software, the executable or the deployed hardware software, and a controller test harness meant that we could test all the functionality of that controller without having to test the GUI or without having to try and press buttons on the GUI during like a CI process, something like that. So just meant we could run some full testing on all the modules and integrate that together and run through test sequences with from a CI perspective. So yeah, I'll just run into that a little bit, I think. So as you can see on some of these modules, we've got things called test harnesses. I'd say that in sort of working through this project, we definitely evolved our ideas on how these were tested. I mean, like, it was our first effort on really producing something in Act Framework, and some of these modules have sort of tests built into them, such as like the error module. We've got sort of unit tests sitting inside the module itself or the library. But then for some of the sort of bigger modules that came a bit later down the line, certainly like the DAC, we started to build that outside the module, just because it meant a little bit more separation and flexibility. But also in these cases, we ended up having to build like a second actor, sort of a test actor that kind of mimicked it, but sort of inherited it, but also added to it so that we could sort of get into the messages and things like that. So what I'll show you, I think, is how we run those tests. So what we came up with was for each of the actors, a little test harness. and it's a real nasty looking thing, so bear with me. But what we found is that we needed some way to send messages to this actor, and also some way to do that in a general way. So rather than creating something, rather than sort of creating a load of messages that we then have to sequence and sort of do that manually for each different test, we created this tester which we can launch this, and we can run, and we can send all these messages, and we can test which responses we're supposed to be getting. Yeah, there's a lot of learning that we gain from doing this, because it's quite convoluted in the way we do it. But essentially, this sets up the first message that's sent, and then there's some additional. So this sends the result, and basically what each message that we send then is sort of triggered by a previous message. So it's like it essentially creates like a little test sequencer, and it sort of works so each message that goes before has then triggers another message, triggers another message, until you get to the end, and then it's done. If that sequence doesn't work, or we don't get the right messages back, then it triggers an error, or gives us a fail in the testing environment. So from Karaya. So I'll just run it, and you can see what I mean, hopefully. But yeah, basically that's run through, and what have we got there? It's running through, doing lots of stuff. So running through that test sequence, and you can see that it's given us a true, everything's occurred in the right order. So what we're doing there really is sequencing all these messages that we have in this one, and just checking that they work in the right order, in essence. So yeah, don't know if anyone's got any questions so far. Tried to whistle stop tour that a little bit.
Hi Chris, can I just jump in with a super quick one?
Yeah.
Hopefully. When I'm trying to get VIs to show in subpanels, I always have to mess around with closing and other sort of things. Can you show me the logic that you've done? Just because I've never found a really nice way of doing it. I'm just curious what everyone else does.
Yeah, I think I've had similar issues in that you never really know what state that VI is going to be in, so you've got to make sure it is actually closed before you put it into the sub panel. I think it's the main difficulty. So that should be in our sub panel. So that's that. I think the magic is done in our change subpanel message. Yeah, no, actually, yes. In this particular case, what we did was all these subpanels are running all the time, right? So all these actors are running in the background, and they never closed. So actually, the logic of doing that became very simple, because you're not having to make sure their front panels have been closed or anything like that. You're just inserting them without any extra issues. So it was pretty straightforward at that point.
Cool.
But
thanks.
I do know what you mean in terms of you get all sorts of strange issues if you have VIs that are open. I think the fact that these are clones, they're not single instance VIs, so that helps as well, because you're always opening something that's not already open, if that makes sense.
Yeah, thank you very much.
Yeah. Reentrant is the right word. Yeah.
A quick question from me. So I've not used Actor Framework in Anger before. I've noticed you've got virtual folder messages for this actor.
Yeah.
It looks like that's full of classes encapsulating the messages for this actor, I would imagine. Is that?
Yes.
I'm guessing that's how Actor Framework is structured. I'm guessing they're enqueued and then handled by your actor core. Are they? Can you just trace through the usage of those classes?
Sure, yeah. So yeah, every message for an actor is a class. So it's a message class. It's got a send, which you use on your diagram. So like this one here is a send insert subpanel. So that gets sent to a sent to this. Let's just dig into this one a little bit. So that gets sent to the actor, and then the actor itself gets this do message, or handles this do message inside it, and that then calls the method that you have inside your class. So it's a way of sending a class method to a class without actually having to put that method inside someone else's class. But yeah, they're all each of these basically inherits from the base actor message class in the actor framework. So for any of the, so because this is an actor, for any of these methods, I could actually create a message for it by doing that. Do it now. Doing some stuff, some scripting going off in the background, and it's still going. It's on my other screen. So you can see that now I've got a set pause message, and it's done all the stuff for me. Diagram, but this, I mean, what's really useful about this, the ACT framework, how it works. It didn't used to be so simple, I don't think, in LabVIEW, but the now if I was to change that method, so obviously this set pause has an input called pause. When you send this message to it, you need to send that pause input with the message. If I was to change that to a string or something else, let's say numeric, it's going to break it obviously, but what I can do then is rescript that message, and it should update it with the input. So you kind of, you don't have to manage, like rebuild all those things. It's a lot simpler than it used to be. I think you used to have to do that manually. So it's pretty,
yeah, which is the extent of my knowledge. Last time I tried using it, you had to do it manually, and I was going to ask how did you find the overhead on setting up all those message classes, but you've answered that question. Okay, could you just open up your block diagram of your actor core just quickly?
This, which one?
I'm just intrigued to know how that's consumed in a core.
So what, the message itself? So you don't see that. That's the magic of it. Everything happens inside the kind of the actual actor framework, actor core. So whenever you receive a message, it's going here, right? So this is the when you dig through these I should have shown that as I went through. Let me just show. Let me just go through that properly. So this is the controller's parent. So this is actually the abstract controllers class, and then inside that, because the parent of that one is the actor framework's own actor core, that is what we see in. Where's it gone? There, and this is where your messages are dequeued and dealt with. So what you got to realize with this kind of architecture is that everything happens in there. So if you were to kind of branch this the class itself and pass it into this into your kind of let's do it on a front panel. If you're doing it on in passing it into the event loop, then anything you do here isn't present in this controller in essence. So you kind of you've got to be really careful about kind of where you do stuff like that. You've got to make sure that essentially, if you want to act on the current actor's data, then you've got to send it a message and do stuff with that inside that method for the message. Yeah.
Okay, cheers. Really interesting.
Right, I'll try and finish off. I think I was actually on the last slide there, so I'm just going to try and finish off this. A bit of a recap. So we went over architecture. I'm just going to do it from here because it's annoying having to keep sharing it. But essentially, we went through the architecture, we did the software modules, had a look at the GUIs, the hardware interfaces, a bit about the testing environment. I know it's been quick and dirty. I guess one of the things that would be quite useful is, or I'd like to run through, is just some of the things that we found were quite nasty and we didn't like, and we've tried to learn from since. I think this test harness was one of the main areas where we've seen it's not very user friendly. And we kind of repeated it on lots of the different actors as well. So we've kind of been through that now, and we're starting to work on, or we have put a lot of work into kind of making that a lot more compact, text file driven, so that we can kind of just set up sequences in a row in a text file. Sequencing in general is a pain. So the controller actor, if I can get rid of that, the controller actor itself ends up with a huge number of messages, and you've got to try and sequence those messages. You've got to try and put your business logic of sequencing what happens when this happens, and that side of things is really difficult in terms of just keeping track of where you are. So you can see there's loads of messages there, and then you've got that's just for the GUI side of things, but for the controller you've got another lot of messages, and it becomes quite difficult to sequence. So we've also been putting a lot of work into getting that sorted. This big cluster setup means it's really difficult to see what your test's actually doing. So we've kind of, again, like put that into a nice text-based sequencing structure. Having too much scope per actor is quite tricky as well. I don't know if you looked at the, well, we didn't look at the DAC side of things, but for this, we actually did all the analog inputs, the analog outputs, the digital inputs, digital outputs, and some other things as well. And what that means is whenever you create a simulation actor, or like for the LabJack, or if you wanted to create something for like a different bit of hardware, if you were harvesting this DAC actor off for a different project and using it on lots of different projects, say, every time you add a bit of hardware, you've then got to create all the well, it's through this interface actually, not that one, this one. You've got to create something that does all that functionality when you might not really need it. So what we've started to do is make smaller scoped actors that just do analog input, say, or digital input or analog output. That's been a nice little find. yeah, I think some of those are pretty repetitive. But I just want to say a quick thanks to Craig Melling, who worked with me on this project, and for him sort of dragging along behind me and riding the learning curve on this one. To James, who's continuing to take things to the next level on this active framework journey that we're on, and for Chris for giving us the opportunity to get into it, and Environment for putting their trust in us for getting it done, which we did. So, and also thanks to everyone else for listening.
Awesome. Good stuff, Craig.
If you've got any more questions, let me know, but that's it.
Yeah, absolutely. We can pick up some questions, but we'll take a quick break as well, I guess, and probably go for 10 minutes. So just short.